Hello, everyone, and welcome to the 24 Hours of Pass Summit Preview. We're excited you could join us today for Kendra Little's session, Why Did My Clever Index Change Backfire? So I think this is a really interesting topic for a lot of people, myself included. Just as a quick introduction, my name is Anil Desai. I'm an independent consultant based in Austin, Texas. I do a lot of work with .NET and SQL Server. And for the last 12 years, I've been a Microsoft MVP in the area of Azure Cloud and Data Center management. So we'll jump right into this topic in just about 2 minutes, but before we start that, I wanted to just mention, if you need any technical assistance, just type your inquiry or question or comment into the question pane on the right side. Kendra has been brave enough to let me interrupt her if there's anything that we're getting lots of questions on. But if it's something else, I'll either answer it myself or provide you to some links for some more information. So we'll do that. You feel free to ask questions anytime during the session through the chat window. You can maximize your screen with the zoom button that's on the top of the presentation window. So if there's some parts of or scripts and things that you can't read, you can always maximize that to view it a little bit better. At the end of the session, we'll have a short evaluation. So please fill that in if you can. Next, I want to thank all of our sponsors, Quest, Melissa Global Intelligence, and Nutanix. The staging of 24 Hours of Pass would not be possible without their generous support, and they're the reason we have this free event available to all of you. Okay, and I'll mention a little bit about PASS as well. For more information, you can always go to pass.org. It's a professional association of SQL Server. You can access a lot of online training and content on demand. You can join local groups, so if you want to meet other SQL Server or data-related specialists in your area, you can find those. But there's also virtual groups as well, so you can interact with others online. You get advance notice of member exclusives and discounted rates on specific events. And finally, speaking of events, the upcoming PASS Summit will be October 31st to November 3rd. It'll feature over 200 sessions with with world-class data experts. So it's the perfect place to connect, share, and learn from industry experts from around the world. So if you want some more information on that, just go to passsummit.com. Okay, that's it for the introduction material. I'm going to go ahead and hand it over to Kendra, who's going to talk about why did my clever index change backfire? Kendra, go ahead.
All right. Hey, folks. My name is Kendra Little, and I make videos to help people learn SQL Server by solving problems. I am a Microsoft Certified Master in SQL Server, and what that actually means is that I achieved a big certification, and I did it by making a lot of mistakes. And these mistakes weren't due to lack of effort. In fact, a lot of the mistakes that I've made over the course of my career is that I thought I'd found something really cool that was going to solve a problem in a super awesome way and speed up performance. And one of the big areas that I made these mistakes in was indexing. And that is kind of natural because indexes are these really cool tools that we can often use to get huge improvements in performance. Indexing is one of those areas where when we find a fix that works, it can take something from incredibly slow to incredibly fast. But when it goes wrong, it can make things even slower or fail altogether. It can make things much, much worse. So like all of those videos you find on the internet of the wagging dog who happily sees a treat or a toy heading towards its face and then just has it bounce off. I mean, I don't know about you, but I could watch those for hours. This is the SQL Server indexing version session of that toy. You're like, it's gonna be awesome, it's gonna be great. And oh, it all went terribly wrong. We have to recover. I will be sharing 3 blunders in the session today. And this is a preview session. I am going to mix this up at the summit itself and mix in different blunders. So if you're at the summit, you won't see the exact same blunders. You'll see some different blunders mixed in there. But the ones today are pretty good. We're going to talk through the filtered index that literally couldn't even, when an indexed view gets ugly, and the case of the disastrous index computed column. Now, some of these are blunders that I've made, and some of them are blunders that I've helped fix. I feel the same sort of pain for them all. So they're all things that really can happen to good, smart people. So first up, the filtered index that literally couldn't even. Let's say that we have this new process at our office for flagging rows. We've got a table that has hundreds of millions of rows. It's pretty narrow, but it's got a lot of rows, and it can have a lot of modifications made at once. Now, a small percentage of these rows are going to be flagged for review, and after the row is reviewed, the flag is cleared. So this is just a really small percentage of rows where the flag column is going to have a review value in it, and it can have a value between 1 and 5. Now, this sounds to us, this new process, when we hear this, we hear, oh, okay, this is going to be a really selective value in this column, a small percentage of the rows. So, you know, this is a long table with hundreds of millions of rows. The queries looking on it have just a simple predicate on it, right? They're looking for where flag equals a value in a list of values. We don't need any functions or anything like that. This sounds like a case where a filtered index could be a really good fit. It'll be a really small index compared to the size of the table, and it'll be really lightweight. As modifications happen, whether it's a new row or setting a flag or clearing the flag, right, the filtered index will automatically just contain the rows with the filter criteria that we set. So that sounds cool. Let's take a look at a demo of how filtered indexes may not be as simple as we think. The demo data set I'm using today is baby name data. It's all of the babies born in the United States. And this is published by the United States government. I just took, they publish it under a Creative Commons 0 license where anybody can do anything. I just took the baby names data and put it into a SQL Server database. There's a little bitty download of 11.6 megs. And then I expanded the data and ran some modifications so that I could have some large tables. So the downloads for this are on the 24-hop site. If they're not there yet, they'll be there soon. And you can run this whole demo yourself and make these blunders yourself. For our flag problem, to start out, we're doing things right? We're testing outside of production, right? We're being safe. And we have a procedure named review flags that I'm going to create. Review flags takes flag as a parameter for the procedure, and we do a little bit of data validation on the values and then say, okay, we want the rows from our table. This is our table that has hundreds of millions of rows. It has one row for each baby born between 1880 and 2017. And we say, okay, we only want that rows where the value is equal to the parameter value passed in. Before we create that index, I'm going to turn on my actual execution plans and go ahead and give this a run just to see how, if we were to scan the entire table, because we don't have any index on flag yet, what is our performance like before we get started? And this takes about 12 seconds to run. Here's my execution plan. Before I get started, I have to do a clustered index scan on the table with one row per baby, and I'm doing a hash match operation. I'm going to just confirm in my execution plan properties. Oh, and I managed to close it, so let's reopen it there. In my execution plan properties, since I'm running SQL Server 2016 and I have an actual plan, I can confirm that my elapsed time was close to 12 seconds, and I had about almost 39 seconds of CPU time, right? So this is a feature we got in 2014 SP2, the ability to see some pretty cool information in our plans. Well, let's create our filtered index. I'm creating the index on the flag column, and the procedure is selecting 4 other columns. So I'm putting those as included columns in the filtered index so that it doesn't have to go do a lookup into the table itself. But I only want rows where the flag is 1, 2, 3, 4, or 5 in this index. I don't want anything where flag is 0 in there. And just for fun, I'm setting data compression to row. In SQL Server 2016 Service Pack 1, as of that and later, we can now use data compression even in lower editions of SQL Server. And we can use filtered indexes in all editions, which is really, we've been able to do that for a long time, since 2005. So that's really cool. This feature doesn't require expensive addition. So I'm checking out in sys.dmdb partition stats. How big is my filtered index, this thing on flag? Well, I have very few flagged rows. And if I drag my row count column over, here's my clustered index of the table. My clustered index of the table has, as I said, like 340 million rows. My filtered index has only 687 rows. And so the amount of space needed by my filtered index is tiny. You know, my table is more than 6 gigs. My filtered index is less than 1 meg. So even if we have to scan this filtered index, this should make things way faster. Let's check out, is our procedure going to use it? This time I'm going to do estimated plan, either Control L or this button up here. And looking at my estimated plan, I'm testing this out and I see, hey, wait a second. When I look at my estimated plan here, I'm still doing a clustered index scan. I'm not using this non-clustered index at all. I'm looking at the ref.first name table and the first name by birth date 1880 to 2015 table. It's not using the index at all. Well, it turns out that parameters, and we figure this out before we ever ship it. It turns out that parameters are a problem when it comes to filtered indexes. This flag parameter could be 0. And we're saying we want to compile and cache an execution plan for any value of flag that comes in. If SQL Server caches an execution plan for one of the times when flag is not set, like it could only use it for a subset of the queries, and this procedure could be run. SQL Server doesn't kind of put together that we disallow some values from here. It doesn't understand that. It's just compiling this query, and it's like, oh, I'm not sure if that's safe. We can actually see that back in our estimated plan. I'm going to go back into my estimated plan here, and if we look here, there's a warning on the select. There's a little warning sign. So I'm going to look at the properties when I'm on my select, and if I scroll down in the warnings, it says, well, I'm warning you about unmatched indexes. There were indexes that potentially I could use, but I couldn't use them. And if we expand unmatched indexes above it, it gives us the reason. The reason is parameterization. I think I could use this for some parameter values, but not all. And it gives us also the index name. And if I expand up my index name, let's see if we can get our column in there. It is in fact our filtered index that's in flag includes filter, that it says, oh, it wasn't safe to use this. There's a few approaches that we could take to get this working. One of them that you might read about on the internet is using a recompile hint. But if we do that, every time that someone runs our procedures, they're going to have to, SQL Server will have to compile a new plan that can't be cached and reused for anyone else. And since recompile means don't reuse it for anyone, SQL Server says, oh, I can use whatever index I want for this parameter value because no one else is going to reuse it. But that is literally, it can be expensive. We pay CPU for every time we compile. So I usually look for a different way to solve it. And dynamic SQL is one way to do that. So I say, okay, I'm going to declare a variable named dynamic SQL, and I'm just going to put this flag value in as a literal value. So I will have up to 5 execution plans. Because this could be compiled for flag equals 1, 2, 3, 4, or 5. But for each of those 5 execution plans, it can be reused whenever that same flag value is passed in. So I won't have to compile it every single time. Now that I have fixed this, I'm going to go ahead and run this with actual plans for flag equals 1 and flag equals 2. This took 12 seconds doing the clustered index scan. And now it's really fast. For flag value equals 1, we have some odd names to review. And for flag value equals 2, we don't actually have any rows. Looking at their execution plans, they got different plans, which is actually pretty good. So flag value equals 1 got a merge join and used our non-clustered index. So if I zoom in here on the object name, right, this is our filtered non-clustered index. It went ahead and it was safe to use it because the dynamic SQL actually has the literal value of 1 in there. For the flag equals 2, it chose a nested loop plan because it was able to use statistics to compile each plan. And if I run these a few times and then look at my execution plan cache using sys.dmexec query stats, I can see that the plans are getting reused. I have 2 queries, one for flag 1 and one for flag 2. I can see that one of them does 8 logical reads and the other does 1600, but the number of times this number column is, they've each been run 4 times. So I'm not creating one execution plan every run. I am able to reuse my plans. I'm just going to have I'm going to have 1 plan per flag value. So I've kind of hit this nice middle ground by getting execution plans that are very high quality and tailored to the query, but not creating a ton of them and not recompiling every time. So I'm like, okay, well, I have figured out a lot of great stuff. I've avoided all these pitfalls with the filtered index. I'm ready to deploy it to production. This is going to be great. But there's something that we missed. What could go wrong that I haven't tested for? Does anyone have any ideas? And if you can type into the questions box. It doesn't have to be a question. You can put your idea in there if you've made this blunder. And I have made this blunder where I did really careful testing and I said, okay, I'm going to make sure that my filtered index will improve performance really big in one area. And we tested it carefully, we deployed to production, and here is what happened to me. It turns out that the application in that environment had different session settings. I was testing from Management Studio. And when this application connected to the SQL Server, there are all these little different set options that Management Studio does and other applications do as well. Things like ANSI nulls, ANSI warnings, arith abort. They have settings they set for those, and different applications have different defaults for this. The application in this environment had ANSI null set to off. And here's what happens when you have a filtered index on a table. I have a filtered index on this table. With set ANSI nulls off, we're just simulating what happened to the app. When I attempt to do an insert, the insert actually fails. The insert, and it gives you a nice, really clear description if you can see the error message, right? The insert failed because the following set options have incorrect settings. And by incorrect, it means that it is not compatible with a filtered index. To use index views, indexes on computed columns, or filtered indexes, or ye old query notifications, which we don't have anymore, we have to have the application have some required settings, and to even have been able to create this on the table had to have been created with a session using those settings. But the table was fine. I was able to create the filtered index, but the application, and I'll give you a hint, the name of the table that I had this blunder on, the name of the table is something like dbo.orders. You don't want to make a blunder on a table named dbo.orders. Now, in this case, this failed, so rolling back, it rolled itself back in this case. And I'm going to reset my ANSI null setting. To fix this, you can either change the set options the application makes when it connects, and that's ideal, but that's usually not a quick change. Or if I just drop my filtered index and clear it out, we're back to normal now. And I'll just show you, just under normal situations with ANSI nulls off, that insert works fine. It was only when I created the filtered index, which was going to help this select query's performance, that I had this accidental blunder of making insert fail. So we had to drop the filtered index to get orders to be able to place again, right? Very desirable. But yeah, over time we did have an item, like on the list of changes to change and test changing the application settings so that we could use filtered indexes, index view, and index computed columns, but it took a while to get that change made. So that was a sad, sad day for my filtered index. Let's get our slides back if we can. But, I learned to always test carefully. Not only does it work in Management Studio, but is the application able to make modifications before we create the index in the production environment? There is a great Books Online article if you know what to search for. I always search for the title, Set Options That Affect Results, and it gives you the required value. You need this required value for the filtered indexes, index views, and index computed columns. But as you can see from the table, different things have different default values. So it's not unusual for this problem to happen sometimes. The blunders I think to look out for with filtered indexes are first, just don't assume you can create it. Because if the table was created by someone who had session settings that don't match with this list, you may not even, when you try to create the filtered index, you may get an error. But just because you're able to create the filtered index, don't assume that your code will use it. Parameterization is the #1 issue. There are other reasons your code might not use it, but usually it's parameterization that might not. So look in the execution plan for that warning, and then test from the application that modifications still work before you go live. Now, those ANSI settings are not the only type of blunders that I've made with these objects, and that I know a lot of people have run into these objects. Index views are fantastic, and they're a tool that I absolutely love in SQL Server, but they get, how on prescriptions you can have those lists of side effects. Index views do have a list of known side effects. And in our case now, let's say we have a different need. There's a new aggregate query that we need to support. And again, it's the same table that has hundreds of millions of rows that can have lots of inserts. But it only has one join. It's a pretty simple query. It doesn't have anything weird like self joins or things that aren't allowed by index views. And it groups by the year function on the fake birth date stamp column. Now, the column is named fake birth date stamp because we only get aggregate data from the US government, and so I faked out birth date stamps so I could have 1 row per baby. So it really is fake. So this sounds like a case for an index view. An index view is going to be great. It groups by defined column. We want it to always be up to date. Indexed views materialize the view. And so inserts, updates, and deletes are automatically to the base tables. They're automatically reflected in the index view. But we've never actually used one of these in production before. So as you can guess, something may go wrong. So let's take a look at our indexed view here. Our indexed view demo. Let's get our query going before we add the index view. I'm going to turn on actual plans, and this is the query that we need to index for. It's grouping by first name and then the year on fake birth date stamp, and we only want to return about 100 rows. Sometimes we may put a where clause in here, right? We're doing order by account star descending. And this table has 300 million rows. So this takes some time. Here is a record from a time I ran it before, where it took 62 seconds to complete. This is the output from statistics.io that I ran this before in the session. And we can see that it has to do 831,000 logical reads against the table. We're doing some tempdb stuff with the work file and the work table, and we're burning a lot of CPU to group these hundreds of millions of rows. So we're at 57 seconds, right? We definitely need an index. This is not something we could just run over and over again in an active production environment if we want this to be fast. So it's at about 1 minute and 11 seconds now. Man, let's see if we can get this query back. So it's taking a little longer on this run, probably because everyone's watching. Oh, wow, we're at 1 minute 30 on this run. So it takes some time. Under the best of circumstances, it takes 62 seconds. So let's see if I can see what's going on. I'm going to do a new window here. And then I have, okay, it just finished up. Of course, when you go to look at it, it just finishes up there. So here we have our query and our execution plan. And we can see that we had to do that clustered index scan. And we've got a couple little warnings on here where SQL Server says, hey, you know, I had to spill to TempDB. It didn't spill a lot of pages to TempDB, but basically we had some problems where we hadn't allocated enough memory, and that's part of what slowed us down, but also me just running other stuff on my laptop did it too. Had another warning here with another TempDB spill on a sort. This one was bigger. We definitely, and we had to allocate a lot of memory for this thing. So we definitely want to do something with this. I'm going to go ahead and start this code to create the index view, and now I'll walk through it because it takes another minute for it to kick in there. So while it's running, we decide to test out our index view for this. Our index view, we have to do a couple things special to get it to work. When we create the view, we have to use with schema binding on it. If we don't do this, when we go to try to index it later, we'll get an error that says you didn't use schema binding. And schema binding is essentially a promise to say, I'm not going to modify the tables underneath the indexed view. If I'm going to modify the tables, I have to get rid of the index view, make the changes to the tables, and then put it back. And that's kind of, I mean, it makes sense that you can't do that, but that in practice does mean whenever, you know, you're going to be altering around tables, you're going to have to drop the index view, which means an outage for anything that's referencing the indexed view directly. We also had to use count big in our index view. Our query just wanted count star, but if we are going to create an indexed view, we can't use count star. We have to use count big. That is not generally a problem. Count big essentially just outputs, in case we have very large numbers, it wants to make sure that it's going to use a big int, and using count star in a query will match to count big. So that's usually not a big deal. We didn't put our top in here. We didn't put our order by in the indexed view. At the point where I created the clustered index on the table, and you have to create a unique clustered index first, that is when I materialized the index view. So this just finished up, and essentially what it did when I created this index is it created a fake table. It's almost like a fake auto-updating table that has the data grouped by these columns in it. So let's go back to our test query, which is a little different, right? It has a top 100. It has count star instead of count big. It has an order by at the end, but I noticed that I have not changed it to use the index view. This is the name of the base table. The indexed view has first name count by year in the name of the view. So I haven't modified my query at all, and I'm just going to go ahead and run it with actual execution plans on. And wow, that did not take a minute at all. That took 0 seconds. Looking at my execution plan, we have a clustered index scan of a view clustered. It auto-magically looked at the SQL in my query, and it says that matches the definition of the indexed view. That text matching feature is an enterprise feature, and I'm running developer edition, which has all the features of enterprise. So that won't work in standard edition or other editions. But it is really, really cool, because let's say if my query doesn't have to name the index view by default, and then I have to drop the index view briefly, well, my performance will stink, but at least my query won't fail, right? So that enterprise feature is really cool, and it automatically matched it. But if I do want to make some changes to it, like, okay, this time I want to say, okay, I only want the top 100 names, but for 2015, not for all time in the table. If I look at the estimated plan on this, we don't have the indexed view anymore in our estimated plan. Adding that where clause, let's get our query back on the screen there. We now have a clustered index scan of the base table. We're going back to rerunning the query and doing, you know, hash join, all that stuff again, because we messed up the text matching. we can rewrite our query to use the indexed view. And I'm going to refresh my IntelliSense with Control Shift R because it hadn't caught up with me yet there. I can reference it by name, right? So now I just rewrote my query to use the index view. But looking at the estimated plan, even though I am referencing the index view by name, SQL Server expanded the query. And it said, oh, I don't think I should use the index view. I'm going to go use the base table. And this would put us back at like a minute runtime if I was to run this. So sometimes what often happens, we have to do this in standard edition. And often if we're going to do things in enterprise edition that make the matching not quite perfect, we have to use this with no expand hint that says do not expand it. And referencing the view by name, I'm going to do estimated plan on this, referencing the view by name and saying, no, really use it with no expand. Yeah, now it's using our index view again. And if I actually run this, I'm going to get the quick 0-second runtime. So we go through all this stuff. We're testing it. And we're like, okay, this will work. We've figured out where we need to rewrite the queries and use no expand. We're ready to deploy it. We figured out everything that could go wrong here, right? We did our due diligence and we deploy it to production and then something goes terribly wrong. Does anyone have any idea what we could have missed? Has anyone had this problem with index views before? It's different than the filtered index problem too, I promise. Well, the problem is again with modifications, but our blunder is totally different this time. We get a report that every time a process like runs that has new babies come in and their name is added to the ref.firstname table, it becomes incredibly slow. And let's take a look. I'm going to use my little Management Studio drag down feature here and just go back to the definition of my indexed view in the top pane. Notice that my index view does join to the ref.firstname table based on first name ID. That is part of my indexed view. We're using table with hundreds of millions of rows, the first name by birth date table, and then tiny ref.firstname is only 3 megs. It's a little reference table that just has a distinct list of first names. So let's take a look at this problem that is happening now. We get this report that inserts are really slow. So I start my insert and notice that I'm not doing a select in this insert at all. I am doing an insert with values and I'm just inserting a new row into ref.firstname, which is 3 megs. And this process that loads these is said to be taking a long time. We're already at, for this tiny insert, we're already at 19 seconds. And this seems like it would be blocking, right? So I'm going to go over to my extra query window that I opened here, SQL Query 1. And I have this free tool called SP-Who is active programmed to Control 0 on my shortcut. I'll just type it in here. So it's basically running SP-Who is active. It's a free procedure from Atom Mechanic. And here is my insert. It's been running for 35 seconds. And notice that it has no waits. It has no waits at all. And blocked by? It's not blocked by anyone. But it's done 754,000 reads. And if I look at its cached plan, SP-Who is active, I have programmed to Control 0. I have it with get plans equals 1. If I look at the estimated query plan, and I look at the estimated cost of this tiny insert has an estimated cost of $2,548. And when I go over and look at parts of the plan, I think I see why. There is a clustered index scan going on of the first name by birth date table. Now my insert is going into ref.firstname, not into first name by birth date. But the execution plan for this tiny insert, and like just, I'll insert into ref.firstname, right? Like if we look at the query at the top, I'm not making this up. It's a little weird. How could this insert take this long? But we're going to have to look at all of the rows. All 300 plus million rows are going to have to go into a compute scaler, and then we're going to have to do a bunch of stuff with it in order to do this insert into ref.firstname. Well, let's go back to our index view here. my statistics time and IO output confirm that to do this insert, we had to do, this is the number of pages, right? We had to read 829,000 pages. That's our 300 plus million pages, or million rows. We have many rows to a page. And it took 55 seconds to do this insert. If I have the luxury of looking at my execution plan for this, I can see that it really did actually have to do that big clustered index scan, and the estimated number of rows was not wrong. This is, I'm going to go ahead and roll this insert back. This is for a reason. Looking at our indexed view definition again, back at the top, what happens with this is whenever we insert a row into either of the tables, we have a join between two tables. Whenever we make a modification to any of the tables in the index view, SQL Server has to figure out, do I need to go update the indexed view? And in this case, just putting a row into ref.firstname, it has to say, do I have a corresponding row based on this first name ID that's going to be in that index view that I have to update? So it goes and scans the other table. We need to provide an index on the first name by birth date table so that it can efficiently find the related rows. So we need an index to support our indexed view. The execution plan actually asks for a good index in this case. What we need is we need an index on first name ID, and then we're also using fake birth date stamp from that table to group by and to select. So including that column helps. So we are going to create an index, and it takes a while to create the index. So I have created it in another database, like I pre-baked the cake in another database where I have the index view, and I created in that database IX help my index view on first name ID include for fake birth date stamp. The database it's in is called Babby Names Fixed. And this is not a tiny index because it's a regular old non-clustered index on that table. I didn't use row compression, so my non-clustered index ends up being actually a little bit larger than the base table. The base table is like 6.3 gigs. My non-clustered index is like 7.7, 7.8 gigs, right? So it's not small. But once I have the right supporting index, I can insert, and I'm inserting the exact same value here. I can do my insert in 6 milliseconds, right? This is much more like what I actually want. And when we look at this, yeah, I did have to go read from first name by birth date, but I only had to do 5 logical reads. Looking at the execution plan, it's a very similar shape, but now instead of having to do a clustered index scan to get the rows I need, I only have to do an index seek. This is one of the big things that can happen to folks when they create these index views. And I am going to roll back my transaction. I do this just to make the demo really easily rerunnable so that, you know, you're not trying to insert the same name again and again. And now I'm going to go ahead and clean up the Babby Names database to make it rerunnable as well. This is a lot of times with indexed views, there's this phenomenon where people say, we tested it out and it looked great, but then we deployed it and it was a disaster. And usually it is an index view that has joins in it and inserts were slowed down dramatically. And the issue was that nobody tested and made sure that they had the supporting indexes on the tables so that those modification queries would be fast. The other things you need to look out for, you got to look out for the same set options thing we saw with the filtered indexes. You may need to change your queries and use no expand. Even in Enterprise Edition, you may need to do that for some queries. In Standard and other non-expensive editions, you're definitely going to have to do it. And absolutely test all those modification queries, ideally from your app so that you know that your set options are fine too. But definitely look and say, okay, how long are our inserts taking? And have we slowed those down? So that way you get to keep your index view in production. The third blunder is the disastrous index computed columns. And this blunder has a special place in my heart because the place I found this blunder with actually some of the smartest people I've worked with. I had a group of people call me into second check. They're like, we don't know why our performance is so slow. And these folks were super smart. And it was one of those things where going in, I was like, they're really smart. So, you know, like this will be a challenge for me to find what they haven't seen. And it was a case of a disastrous index computed column. Let's say for our scenario that we want to help out our users. It's like a Friday afternoon and our users, they're actually pretty good users, you know, users, they just want to do their work. And they have this user-defined function that they put in a lot of their query predicates. And it's against this tiny table in our database. So we think, you know, we could actually create a column for this, you know, use a computed column to pre-compute these values for them. And we could even persist the computed column to disk and index it to make queries really efficient. And we do a lot with computed columns. We've never gotten this fancy with it before, but it seems pretty low risk because it's this tiny 3 meg table. So let's go ahead and try this out. We're going to test it out before we deploy it. And let's see what's up with our computed column. So we are once again in our sample database. And we first create our function, which is called years used. Years used, this is the function our users often refer to in their queries. In order to do the persisting and stuff later on, we do have to create this with schema binding in order to do the persisting and indexing we're going to do. Similar to the index view, that's required to make it work later. We have to promise not to change the table that it refers to. But this actually, like if we look at it, this isn't even doing data access, right? We're taking in 2 parameters and we're doing a little bit of magic to it and we're returning a value, right? Not super complicated. So now we're gonna alter the ref.firstName table, tiny little 3 meg table, and we're gonna add a column named years used, which is defined as the function years used, taking in 2 columns from the table, and we're going to make it persisted. So first report year and last report year are columns that already exist in ref.firstName. So now we have a new column on the table, and when we said persisted, it actually went ahead and persisted the values to disk. So it's like a real column, and it doesn't have to be calculated every time the queries run. Seems really cool, right? Well, that is really cool, but it would be even more cool if we indexed it so that we could have a seek on years used. And notice everything was really fast, right? Like this is a tiny table, so these changes, no big deal. So we pat ourselves on the back. It seems like, you know, our users could continue to use the function or they can use the new column. Seems like a nice thing to do. How bad could it be? Well, it turns out it could be pretty bad because there's something SQL Server didn't tell us when we created all this stuff. There's something that went totally unmentioned by the SQL Server. We start getting complaints from users that things seem really slow on the SQL Server, like just much slower than usual. And one user sends us this query as an example, and the user says, you know, this is usually kind of slow, but now it's really slow. Like this query hasn't really been optimized, but like I'm just waiting on it forever now. This is just one example. Everything seems slow. Huh. Well, we go back to, you know, our monitoring stuff and we're like, what's running on the SQL Server? Maybe there's blocking or something weird, or there's a lot of stuff running. Well, right now, you know, I'm running my SP who's active and looking at my dynamic management views. All I've got running is this one query. It's been running for 38 seconds. It's not waiting on anything, like the wait info is null. Nothing's blocking it. What's going on here? So it's 50 seconds, 51 seconds, and I might start doing things like looking at my server wait stats and seeing if I have unusual waits, and things look a little different, but there's no like obvious big reason why things would be slow. Well, I'm on SQL Server 2016, and I've configured Query Store against my database. So I decide that I'm going to look at Query Store as a database level tool that we can use to collect query execution plans and performance information. So this query, which finally returned over here after 1 minute and 9 seconds, this returned. And this was looking at names, like it's looking at our table with hundreds of millions of rows, and then it's joining to that little table where we put the indexed computed column. And it wants to know names for girls that were last reported in 1890. And I want someone to name their baby Pantha, because I think that name deserves to come back. Just an extra thing. There's some really cool names in this list, and I'm like, why don't we use these names anymore? I think they're perfectly good. But back to SQL Server. In our query store, these are just the built-in reports, and I do like to use queries against my query store, but sometimes the built-in reports can reveal interesting things. When you enable query store against a database, it works in all editions on SQL Server 2016 and higher. You get this tracking, and I'm going to open the regressed queries report and just see, do we find any regressed queries? And let's go ahead and pin this guy. So right off, I'm going to switch to this detail mode. I prefer that to the graph mode. I find it easier to use. And our top query here, I'm highlighting it, is in fact select distinct first name. Hey, this looks like our query. So because I just ran this, I luck out and it's at the top of my list. We have 2 different execution plans for it. It was seen in one sample that happened a while back, and then recently in a sample now. And these slower ones, well, let's look at what's different. Here's our fast plan. So if I click on 189, this is by duration. So the lower one is the one that at least at one point was really fast. And this is what the plan looks like when it was fast. This thing isn't optimized at all. That's normal. But if I highlight over here, I can actually see that when things were faster, my duration was like 13 seconds. If I highlight over this blue one here, I can see that the duration was up to 79 seconds. And what's different about this blue plan? Well, we have a totally different plan here. It has a clustered index scan and a hash match. We still have a hash match here. One thing that's really different between these plans, though, is notice all the parallelism operators on the fast plan. It was able to use multiple cores on the fast plan, and my estimated cost here is $1,445. There's a threshold we have on the SQL Server called cost threshold for parallelism. I have that at the default 5, so it's way over that threshold. When we go look at the slower one has an estimated subtree cost that's still way over 5, 2,239. Well, why didn't you go parallel? If I look at the properties on the select, it will tell me a little bit. The non-parallel plan reason is I could not generate a valid parallel plan. It doesn't unfortunately give me any more detail than that. One of the secrets here is that secretly in the background, if you create an indexed computed column, if we create, it's not just an indexed computed column, if we create a computed column with a function, even if we persist it, even if we index it, trying to make it like a real column at all, there is it's not a feature. There is an issue in SQL Server where that means nothing referencing that table can use parallelism. Our query did not reference that column at all. Our query did not care about that column at all. It's simply that the column is in the table and the query has a join to the table, so now the query cannot go parallel. If I remove the computed column that includes the function, the issue is that it's a computed column with a user-defined function. To be clear, it's not just any function, it is a user-defined function. Now when I go back to my query and I look at my estimated plan, now I'm back to parallelism. Parallelism is a great tool in SQL Server, and it can speed up some queries dramatically, particularly if they don't have perfect indexes. We can't provide perfect indexes for every query. But with computed columns, just because we can index it doesn't mean it's good. We could have a blunder, like we have this great plan to persist it and index it, But even with that, we dramatically slowed down anything that touches this table, whether it uses the computed column or not. So although this seems like a great idea, this is one of those cases where you just don't want to use UDFs in computed columns anywhere in SQL Server because of the harmful side effects. If you want to dig into more of the problems you can just get with computed columns, you typically, if you want to use them, you do want to persist them. You don't want to use any user-defined functions, but you can still run into issues. Paul White has an amazing article on SQL performance, digging into lots of things, including cool trace flags with computed columns. So we have about 10 minutes left. Do we have any questions that have come in? Anil?
Yeah, Kendra, this has been going great. I've been following it all myself. So yeah, we had a couple of questions, but I think, you kind of covered them a little bit already.
Oh,
and
cool.
yeah, and also I did send out, if people hadn't noticed, into the chat window, a link to download the scripts that you made available, so they can actually take a look at those as well.
Yeah,
But
yeah, demos are fun. You guys should totally run the demos.
Yeah, exactly. That is great. I love the idea of this database as well. So actually, Albert asked, did you draw those cute pictures yourself?
I did draw the pictures and do the animation. So for the past session, I actually want to have a lot of dog fail animations. So I had that one of the dog with the ball hitting his face. I want to have a lot of them for the summit session. So you should totally come to the past summit just to see my terrible cartoons.
Right. I think a lot of people like them. You're getting a lot of positive feedback here. Did you have anything else before I go comb through the questions? Did you have anything else that you wanted to add, or were you just?
Oh, nope.
No. Okay, great. One of the things I'll just ask, because I run into this a lot with I have and with other DBAs, is if you're using Query Store, great, but if you're not, what is a good way to kind of see either using like Profiler or extended events, or how can you kind of see the impact that you might be having, let's say, by making an index change?
Yeah, well, so that is the great question, and it's really valuable. So that one thing is you want to be able to do this to look out for the blunders, but the other reason you want to do it is you want to be able to show how much faster you made something, so that you can tell your manager, and so that your manager can brag about it, right? Because your performance improvements are not just good for you, they're good for your whole team. So you want to be able to see the before and after. My favorite way, if I don't have Query Store, I think Query Store does make a lot of this easier, but if you don't have Query Store, because we aren't on 2016 or Azure SQL database yet, my favorite way to do it is using the execution plan cache, because it's fast and lightweight. There are queries similar to the ones I have in this, where you could say, okay, I want to see, I'm going to put this index on this table, so I want to see the top queries that use this table and see how much CPU time they're taking and how many logical reads they do, and capture that information before you make the change. Look at the ones that you think are going to be able to use your index, right? So hone in on those based on the query predicates, and then capture the same information afterwards. It's not as easy as Query Store, because if you've got things like recompile hints in your code, things may not show up in your plain cache, but at least you don't have to run like a 5-day trace, right? So,
right, definitely.
You
don't have to know exactly what you're looking for in order to get it to, yeah. No, that's great. There are a lot of questions that came in here, and I'm just trying to pick the ones that are probably the most general. That would probably apply to everybody, but it seems like everyone who's commented agrees that they've really found something useful and practical in this session. So that's always great feedback, I think. Let's see. There was a request. So for those of you that missed it, I'm just going to go ahead and resend that link in the Q&A to download the SQL files that were used in the demos. All of the questions, if we didn't get a chance to get to them here, Kendra will be able to see those, and also we'll keep those in mind as well, so they're not going to disappear. I guess I'll go ahead and sum up right now, a few minutes early, and I'll just say, just coming up next, we have a session on DevOps and the Agile DBA. But actually, Kendra, you have 5 more minutes, and I love listening to you talk. So if you have anything more you'd like to add, any general performance tuning tips or anything, feel free to do that now.
Well, I should actually turn around and ask you. So in terms of that question that you asked me, do you have a different take on it, on how you like to compare the before and after, like what tools you like to use? I'm just curious, because you do a lot of
Absolutely. In fact, you know where this came from is, I've interviewed lots of DBAs or potential DBAs and stuff, and I'll ask them, they'll say, I'll just ask them just general questions and see where they go. So they'll often say something like, I'll say, well, you have a report that's taking a long time to run. What do you do? And they're like, oh, that's easy. Just put indexes on on those tables that are querying. So then I'll say, well, which tables? And then they'll just say, index everything essentially, right? And I think what a lot of people don't look at is the overhead for index maintenance, right? So that's why you often have a data warehouse for reporting purposes, and you also have an OLTP type system for collecting data, and those two things are kind of at odds. So that's that's the kind of question is people are like, why not create an index on every column because they make things faster? And that was my point, is just to make sure that people know. And I think you showed it really well with that insert statement, how much of a difference it can make.
That is a fun blunder that I've definitely too. Like, we have a new database and it's really small and we aren't sure what's going to be slow. So we throw a ton of indexes on it and we can get away with it while the database is really small.
Right.
It's one of those databases that grows really fast. Suddenly we've got terabytes of non-clustered indexes, and some of them are used like once a day. And we're like, what uses this? Is it important? Is it not important? I have no idea. I have to do all this research now and figure it out because CheckDB takes a full day and running a backup takes an hour, and it's all of this load we've put on it. Yeah, I've definitely been there, totally over-indexed that database before.
Yeah, it happens all the time, especially when in your development databases, you have a few thousand rows or something like that. And then when they deploy it to production, it craters when you're looking at millions or tens of millions of rows. Yeah. So that makes sense. Great. Anything else you'd like to add?
Well, let's see, what do we got?
You don't have to. I'm just saying we just have a couple of minutes left. So
Well, I did want to. This is just like, I registered for the PASS Summit yesterday, and I finally made my decision about what pre-con to attend. So I have the time to attend a pre-con this year, and there's really, really good ones. It was hard, it was tough, but I decided I'm going to Nico's pre-con on column store indexing. So anyone in here, if you're also going to Nico's pre-con on column store, I think it's going to be amazing. He's a great presenter. I understand if you picked a different pre-con because there's really tough choices, but hope to see you there. I am so excited about getting to attend the summit this year and also getting to attend an awesome pre-con. I think it's going to be great. So the tough thing is just making a choice about which pre-con to attend, I think. And if you don't have permission to attend a pre-con, come up with different things you could do, different projects you could do with the pre-cons, and try for it. Like, try to make that extra request, because they are just a great chance to get to really learn in depth for a full day. They're very, very valuable experience. So totally encourage everybody to sign up for that. I'm glad I made my decision.
Right.
I actually thought about it for weeks about like, okay, which am I going to pick? So
great. Well, perfect. Thanks so much for all of the information. Again, the next session that's coming up is DevOps and the Agile DBA. I just wanted to thank everyone for attending. We've got a huge list of attendees here, and it looks like a lot of you really got something useful out of it. So one final time, Kendra, thanks a lot for your knowledge and your great presentation.
Thanks so much. Thank you so much for hosting. You were wonderful.
Thanks, sure.
All right, bye, folks.